Okay. So a marketing consultant wants to eliminate or estimate the true proportion of all residents that live near a certain mall who make at least one purchase at the mall in the past week. He stands at the mall exit for 2 hours on a weekday afternoon and flips a coin each time a shopper leaves. If the coin comes back heads, he asks them if they have made any purchases during the visit. After 2 hours, he has 132 responses, 104 who made a purchase. Which condition for constructing a confidence interval has the consultant failed to satisfy? So it may be obvious to you, but it does sound somewhat random, like, oh, he's flipping a coin. But like he's talking to people coming out of the mall, did you make a purchase? Like, this doesn't seem like a random sample. It seems like a convenience sample, but let's just go through the conditions and kind of see. So N is 132. So this would be 132 times 104. So we have 104 successes, right? So times 104 divided by 132 is greater than or equal to 10. That's 104 is greater than or equal to 10. Failures is whatever 132 minus 104 is, which is bigger than or equal to 10. So that's 128 is bigger than or equal to 10. Both of those are true. They pass those conditions. N is bigger than 30. It passes that. So you can just plug in the numbers and see those are okay. Sample size is less than 10% of the population. There's a lot of people at the mall. They only sampled 132. Just in a given day, it'd be thousands usually. So I'm pretty confident that's true. Data comes from random samples. So this doesn't seem like a random sample. What's the population of interest here, right? So we're trying to estimate the portion of all residents that live near a certain mall. So I would want to have a list of all the people that live near the mall, right? That's our population, randomly sampled from that population. They didn't do that. They just, people walking out of the mall who may live far apart from the mall. Like, we don't know where they live. It's definitely not a random sample. It seems like more of a convenience sample. So D is the right answer. Government claims that students earn a mean of 4,500 during their summer break from studies. A random sample of students who gave a sample average of 3975 and a 95% confidence interval is found to be between those two numbers. Which of the following is the correct interpretation of the confidence level of 95%? So let's just kind of say it generically. If we take many samples and create many confidence intervals, about 95% of the confidence intervals would contain the true proportion. So now in the context of the problem, that's generically what interpreting the level is. So the level of confidence, we're interpreting the level here. That's what it's asking us to do. 95% probability, that's not what this is after. It's 95% of the confidence intervals created. 95% probability now. 95% of all confidence, this is at least tempting here. So if we were to repeat survey, about 95% of the confidence intervals would contain the true value 4,500. Well, do we know 4,500 is the true value? So I don't think that's it. It's the best answer we've seen so far. Repeat sample 95% of the confidence intervals, I like that, will contain the true value, whatever that is, of the average. Yeah, that's definitely it. That's definitely it in the context of the problem. 95% probability, that's not it. So it can't be. So researchers studying reaction time of driver states that a 95% confidence interval for the mean time it takes a driver to apply the brakes after seeing brake lights on a vehicle in front of them is 1.2 to 1.8 seconds. So just write that as a confidence interval, 1.2 to 1.8. I don't know what the question's going to ask, but what's the point estimator in the middle of those two? If you average those two, I think you get 1.5 would be the point estimate, right? So that's in the middle. How much of a distance is there between 1.5 and 1.2? So the margin of error would be 0.3 because you subtract those two things. To find 1.5, you would add them up in your calculator. So if you had a calculator, you do 1.2 plus 1.8. Take the answer and divide that by 2. And you get 1.5. And then you take the point estimate, or 1.5, subtract 1.2, and you get 0.3. So it's got to be, there it is. A 95% confidence interval for the true proportion of all shoppers at a large grocery store who purchased cookies was between 23.6 and 28.2%. Which of the following would be true? Oh, wait. I think we just, let's see. Oh, no, this, okay. Which of the following would be true about a 98% confidence interval constructed using the same data? So 95%. Let's think about the formula. So like margin of error, if you multiply the z critical value times the standard deviation or standard error over n. Okay, so let's just focus on this. If z is bigger, it's going to be a larger confidence interval, larger margin of error, right? It's going to be a larger interval. 95 is going to be 1.96. Let's do 98. So that would be, if you do that in your calculator, 98, so 0.98, that means 0.01s on this side and 0.101s on the other side. That's your z critical value. So if you do inverse norm of 0.99, that's 98 plus the 1% on the left, you get 2.32. So 2.32. So that's with a 98% level. Well, it's going to be wider because z is bigger. Z star is bigger, so it's going to be wider. So this 98 is going to be wider. I don't know what the question asks. Which of the following would be true about? So it's going to be wider. So right away you know it's wider. Okay. Because the standard error, not because of the standard error, I think it's a z star, right? It's z critical value. So that's what it is. So researchers studying the reaction time of drivers. So you have 95% confidence interval. Is that the same data? Thought we just had one about this. Yeah, different question, but same data. Okay. Which of the following claims is justified? A reporter claims that any randomly selected driver will take at least 1.2 seconds. Okay, so these are hard to disqualify for sure, but at least 1.2, I don't think we can say that. That doesn't sound right. Reporter claims the mean amount of time it takes to apply the brakes is at least 1.2. Again, I don't like the wording of that. We might come back to those if there's no better answers. Reporter claims that it takes at least 2 seconds to apply the brakes. That's certainly not true, I don't think. Okay, this is looking better already. Reporter claims that it takes 1.2 to 1.8 seconds to apply brakes after seeing the brake lights on a vehicle in front of them. Okay, that's the best answer we have so far. Reporter claims it takes at least 1.5. Yeah, I think D is the best answer of those choices. A newspaper conducted a statewide survey concerning the 2008 race for a state senator. The newspaper selected a random sample of 1,200 registered voters and found that 620 would vote for the Republican candidate. Let P be the true proportion of registered voters in the state that would vote for the Republican candidate. Which of the following is closest to the sample size you would need in order to estimate P with a margin of error of 0.01 and a 95% confidence interval? Oh, and even, that was so nice of them to tell you that. Even use 0.5 for P hat because you don't know it. They didn't have to do that. That was super kind. So 95, we know that's 1.96 for Z star. Square root of 0.5 times 0.5 over N, which is 1,200, is less than or equal to the margin of error, which 0.01. Wait, it's closest to the sample size. Oh, we don't know 1,200, I guess. Okay, so we want N there. Okay, so use your solve command in your calculator, menu 3.1, I think, solve. So 1.96 square root of the fraction 0.5 times 0.5 over N, less than or equal to, control equals, 0.01, comma, n. So 9604, wow, exactly, 9604, there we go. If it was a decimal, we would round up. I kind of wonder if it is a decimal. Yeah, it doesn't seem to have one. I thought it had a little funny mark there. A test of significance produces a p-value of 0.024, which at fine conclusions is appropriate. So 5% level, so accept, first of all, we never accept the null, that's just silliness. Reject the null at 1%, that's 2.4%, that's not reject the null at 1%. Accept the null, we never accept the null. Reject the null, that seems right. Let's see what he is. Fail to reject it, no, it's below. When it's small, you reject, right? A manager wants to determine the proportion P of employees that arrive to work late. She will call a company meeting. If there's clear evidence the proportion is greater than 0.1. She selects a random sample of 30 employees from the 500 employees at the company to test the hypothesis that the null is 0.10 and the alternate is more than that. Which condition for inference has not been met in this thing? So a data is from a random sample. Let's just first check the sample size is less than 10%. So what is the sample size here? So 500, she selected a random sample of 30. So the random sample, so n equals 30 here. It does seem like it's a random sample, so I think that one seems to be met. Sample size is less than 10% of the population. So what is the population here? Oh, 500. 30 is less than 10% of 500, so that works. N times B would be 30 times P hat, which is, or P is, let's see. So P is 0.1 there, so that's just 3. Oh man, that's the answer. Doesn't satisfy that condition. 3 is not bigger than 10. So disappointed. Why not to work? The power statistical test for hypothesis is, so what is the power? I'm saying generically. So assuming the null is true, it's the chance of getting a result as extreme as the sample you got, or even more extreme, or something like that. The smallest significance level, which the data will allow you to reject the null, power of a test. That doesn't seem like it. Power is equal to 1 minus the p-value. P-value is alpha, right? Alpha, no, power is not related to alpha like that. It's related to beta, actually. The probability that the test will reject both one-sided and two-sided hypotheses. I'm not sure about that one. We're going to come back to that one. Probability significance test will reject the null hypothesis when a particular alternative value. That sounds like the definition of power. When you have some certain value, you're trying to see power of correctly rejecting the null. That's exactly it. It is equal to the type 1 minus the type 2 here. If that was type 2, then that would work, but not as it is. I think we already did 10. 10 is the same as 7, I think. Okay. A survey of random sample of 1,280 students, loan borrowers, found that 218 had loans totaling more than $40,000 for their undergraduate education. Construct and interpret a 95% confidence interval with the true proportion. So P is the true proportion of all student loan borrowers who have loans totaling more than 40,000. You're going to say that in words right there. I got lazy. Okay. You want to say the confidence level. So the confidence level is 95%. Okay. Let's go to state. What are we doing? This is probably an interval. Let's see. 90. So this is a 1 prop C interval. Let's name the test. Now the conditions, random sample of what? Random sample of 1,280 students. 1,280 students. Okay, that's the first condition. Second condition, like the less than 10%. So 1,280 is less than 10% of student loan borrowers, right? And then N P hat, I believe. So N times P hat. So 1,280 times P hat, which is 218, 1,280, which is 218, which is bigger than or equal to 10. So if that one's bigger than or equal to 10, whatever 1,280 minus 218 is, so 1,062, I think, is greater than or equal to 10. Construct and interpret this. So we go P hat is, what is P hat for this problem? So 218, whoops, 218 divided by 1,280. So 0.17 is good enough for this, plus or minus 95, so 1.96 times square root of P hat, which is 0.17 times 0.83 over N, which is 1,280. Let's also do this in our calculator. So menu 665, I believe. X, the number of successes, is 218. And the total number is 1,280. And confidence level is 95. So the two values I have to put here. So I mean, I have to put the obviously lower and upper. So 0.1497. How about just 0.15? I think if you round that, because 97 rounds the 9 up to a 0. I think it'd be better to think of it that way. The upper bound is 0.191. Okay, conclude. So we are 95% confident the interval from 0.15 to 0.191 contains the true proportion of all student loan borrowers who have a loan balance totaling more than 40,000. Suppose we want to estimate the true proportion of all student loan borrowers who have loans more than 40,000. Calculate the sample size you would need. Okay, so again, we're plugging that formula, so it'd be 1.96 times square root of, I think we're solving for N, sample size. So this would be sure, P hat here is, I don't know if I did this yet, 218. Oh, P hat 0.17, right? We already did that. Why reinvent the wheel here? So 0.17 and 0.83. And sorry, that should be less or equal to the margin of error, which is 0.01. So you should solve that in your calculator and it should give you the right answer. If you do. For N, well, let me just show you. So solve 1.96 square root fraction 0.17 times 0.83 over n less than or equal to 0.01. Oh, don't forget comma n. Hopefully that's all I forgot. Here we go. So 5421, 5421. Notice I rounded up on purpose there. Okay, so that was the interval. Now we have a test. You're probably going to have a test and an interval on the test. Just going to do the whole 9 yards. Mark a starting pitcher for a Major League college basketball team. Starting player for a college basketball team made only 40% of his free throws. Ah, terrible. Last season. During the summer, he worked on his developing a softer shot in hopes of improving his free throw accuracy. In the first 8 games of the season, Mark made 25 of 40. You want to investigate Mark's free throw percentage for the season is more than 40%. Is there convincing evidence of this? Well, we have some evidence because that's more than 40%. He made more than half already, so it's gotten better. But is it significant? Like, is it convincing evidence or is it not here? So you want to go through the first part here. So we want to say the alpha level is, I'm assuming 0.05. They don't tell us. Alpha is that. Define the parameter. So P is the true proportion of trying to find it in there. True proportion of the free throw percentage during the season, I guess, that he's having. Okay, the null, usually, it's just, in this case, the proportions for sure, because we're talking about percentages. P is equal to, nothing's unusual, it's just 0.4, nothing's unusual. The alternate is a little unusual, so we think if it's more than, so we think greater than 0.4. So that's that step. And then you want to say somewhere on here, it's called a one prop Z test. Check the conditions. Say something about random, maybe random sample somewhere. It didn't say that. I think it's kind of implied here the way they set it up. And we want to do this problem, so we're not going to fix that condition. It's not obviously wrong. Then less than 10%. So what number is less than 10% of what number? So the sample size out of 40, so 40 is less than 10% of all free throws made during the season or something like that. And then N, NP, and then Q. So 40 N times P, which is 0.4, is I think 16, which is greater than or equal to 10. And so 16 plus what? Plus 24 is also greater than or equal to 10 because those add up to 40. So I double check that condition. I'm ready to go on the next step. Z equals, so this would be P hat, which is 25 out of 40. You'll see 25 divided by 40, 0.625. So 0.625 minus 0.4 all over 0.4 times 0.6 divided by n which was 40, I believe. So you type that in your calculator. You can also just do the test in your calculator, right? So menu 675, I think. So the null is 0.4. Number of successes you got, 25. Next line out of 40. And the sign is more than, so we think greater than. Okay. And then, so the p-value says the two things you have to have is z is, well, now I know what it is. If I typed it in, 2.905 and p-value 0.000018, I believe. Conclusion, so because our p-value is so low, because our p-value is smaller than our alpha level of 5%, so our p-value is 0.0018 and our alpha level is 5%, because that's small, we do reject the null. We do have evidence to say that his free throws, he's now making more than 40% of his free throws. So he got a lot better over the summer. Okay. Last question. The National Fire Association has specific recognition about the number, location, and type of smoke alarms are needed to provide the maximum protection for a household. 96% of homeowners have at least one smoke alarm. Recent community surveys have estimated the proportion of homes with sufficient smoke alarm protection may be as low as 20%. Fire marshal wants to determine whether the proportion of homes in the community with sufficient home alarm protection is more than 50%. If this is the case, the fire marshal will then plan to launch an expensive public awareness campaign on the importance of sufficient fire alarm protections. To find the parameter, state the null and alternative hypothesis. So parameters P, the true proportion of, let's see, let me read the context. Proportion of homes in this community with sufficient smoke alarm protection. That's what it is in context. The alpha level, if it doesn't say, is 0.05. And the null hypothesis, P equals 0.2, I believe. And the alternate is P is okay, so it's related to this. I think P is 0.5, by the way, right? It's 0.5, it's not 0.2. Estimated. He wants to see if it's less than 50%. So I think the null is, well, I guess it's 50%. The direction is less than 50%. So that was tempting. I was really tempted to put 20% there for the null, but when you read more of it and read it closely, it really was the other one. Describe a type 2 error in the context. So type 2 is when you fail to reject, but you should have rejected. The null is not true. So you thought the null was true, right? So you're going to do an expensive public awareness campaign, et cetera, et cetera, et cetera, spend all this money. And it turns out like probably shouldn't have, because if it's type 2, that means the null, you failed to reject, but the null was false, that there really is less than 0.5 there. So consequence of that, let's see what they said for this one. Type 2 occurs when you find convincing evidence that for the true proportion of homes in community is less than 0.5, when in fact, the true proportion is really, the true proportion is less than 0.5. Type 2 error, by failing to find convincing evidence. We failed to reject the null, but we should have rejected the null. Null is false, right? Oh no, type 2. You have failed to reject the null, but we should have rejected. So you failed to reject because you didn't think this thing, it's not really less than 50%. It's just, there's nothing going on here, right? So you thought the null was true. It wasn't evidently, but that's what you thought. And so you made the wrong decision there. Fire marshal says that for a sample size of 400, the power of the test is at 5%. For the alternate of 0.44 is only 0.671. So the power is 0.67.1% if the alternate is 0.44. So given that the alternate is true, given that 0.44 is true, there's a 67.1% chance of, I guess, correctly rejecting the null. Let's see what they said for C. True proportion is 0.44. There's 67.1% probability they will find convincing evidence for the alternate. That's what it is, yeah. Finally, based on your answer to part B and C, would alpha be 0.1 or 0.5 be better significance level for this test? This is kind of tough. So this is a one-sided test. I think, the true proportion P is 0.5, and we're shading. Well, where's our sample? We got this says based on B and C, so I think that's 0.44 in the middle, not 0.5, because it changed it to 0.44. So there's 67.4% chance of correctly rejecting the null. Sample size is 400. So which one's a better significance level for this test? Okay, so they got, so if it was 0.44, we're trying to get less than 50%. It's not that big a difference there. I think you would have to, which one would be a better significance level for this test? So it seems like we need more power. This is kind of a tough question, I feel like. So more power. So what if we want more power? Which one would give us more power? If alpha's higher or alpha's lower? Well, alpha higher, this goes in the same direction. So if I raise alpha, it's going to raise power. So I think for this one, 10% would be a better significance level because it's not a huge difference. I'm not sure if I'm going to be able to prove this unless the alpha level is pretty high here. That would give me more power, and I think that would be better here.